Okay, so let's talk about combustion chambers. Now, if I said the word impingement, can anybody tell me what the word impingement means? We talked about it briefly last week. What does impingement mean?
Is that when the flame hits the combustion chamber?
Yeah, it's any time the flame hits the wall of the combustion chamber. The flame is impinging on the combustion chamber. Why is that a bad thing? Okay, if flame is hitting the wall of the combustion chamber, do we have complete combustion going on?
No.
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 Okay, it's all about complete versus incomplete combustion. If I have a flame hitting the wall of the chamber, okay, it means I have oil hitting the wall of the chamber, and it's just going to be incomplete combustion because incomplete combustion is basically unburnt fuel. Okay, we don't want that to happen. So the purpose of the combustion chamber basically is just to provide a hot environment for oil to burn. The air and oil mixture burns best in the hot chamber. The chamber reflects the heat and provides for the containment of the flame. The combustion chamber also minimizes the amount of air for combustion. Let's see if I can give you a picture of why this is important. Well, or describe a picture of why this is important. If I have an oil flame, okay, and if I'm just shooting a flame into a 55-gallon drum, okay, so let's say I have a 55-gallon drum laying on its side, okay, and if I'm just shooting flame into this 55-gallon drum, I have about 55-gallon drum worth of area to heat before I have enough heat to sustain combustion. If I isolate an area inside this 55-gallon drum with a porous material, in other words, it's not a solid wall, but it's a porous material where flame and air can be somewhat contained in here, and then maybe have a smaller passage for the products of combustion, I have a much tighter control on my combustion process. Okay, I can minimize the amount of air required. I have a much hotter environment because it's all sort of contained in a combustion chamber. The heat still gets out of this chamber to the surrounding area and metal, but my combustion process is contained. Does anybody have any questions on that?
No, sir.
Okay. Combustion chambers can be made of fire brick, can be made of metal, can be made of insulating brick, can be made of ceramic, or can be made of a molded material. We are not seeing in residential anymore a ton of brick combustion chambers. We are seeing molded material as our primary combustion chamber now, synthetic molded material. But you still have to know about these other things because they still exist in commercial application or larger applications. Fire brick is a heavier material than insulating brick, okay? In other words, fire brick comes very close to the brick that you see on the outside of buildings. It takes more time to heat up. It's used only in commercial and industrial applications, okay? They're large chambers, and if it's shot, the large chambers that are subject to greater shock need to be replaced frequently. Give me an example of where you might see where a burner ignites and there's a lot of air pressure because of the shock involved in that burner ignition. Where might you see that? Anybody?
Industrial?
Well, industrial, but where in an industrial application? And wrong answers are okay. What about a power plant? You have a massive boiler igniting. okay, gobbling down about 100 gallons an hour of oil. Okay, that's a lot of shock when that burner starts. Okay, those chambers need to be replaced just because of the air pressure when those burners start. Metal chambers. They were primarily the standard for years, factory-built units, but they're very sensitive to improper firing rates. If the flame comes in contact with the chamber wall, a hole can actually be burned through the chamber, okay? Because of oil flame constantly hitting a metal chamber wall will actually weaken the metal and will burn a hole right through the metal. They're not recommended to be used with the modern retention burners. Basically, that's a burner that has a retention head on the end of it. Well, guess what? Most of our modern burners have that. Okay? Metal chambers are replaced with precast ceramic chambers. So in other words, if you're out there and a hole has burned through it, we're replacing these chambers with a precast ceramic chamber. The metal chambers, they were very used frequently for years. But again, they become very sensitive. The metal has metal fatigue after a while and will start breaking down and disintegrating. Okay, so metal chambers are on their way out. Insulating brick is a porous, sort of almost a combination of brick and sponge, I would say, in a dried format. But it's a porous brick. It's extremely lightweight, and it's highly resistant to the penetration of heat. It will glow red in about 15 seconds. Okay? There's different ratings of fire brick that can be used. Up to 3 gallons per hour, you might use a 2,000 degree fire brick. 3 to 5 gallons an hour, you use a 2,300. 6 to 15 and you go up. Okay, over 25 gallons per hour, we use a 3,000 degree fire brick. Okay, now, when you start dealing with 25 gallons per hour of oil, you're dealing with a lot of flame. Okay, a lot of requirements in that range. So, primarily, you're going to, as entry-level technicians, you're going to see probably up to 3 gallons per hour as entry-level technicians. You won't go much over this. Once you're in the field, if you work for specialized companies or go to work for a school district or hospital or manufacturing facility, you'll be in the 3 to 5 and 6 to 15 range. Up over this, okay, you're dealing with massive boilers in a power plant factory or something like that. Okay, and you'll receive specialized training for that because that requires a specialized license. So again, fire brick, you use different temperature, or the insulating brick, different temperatures, okay, of brick based on gallons per hour. Proper cement must be used when you're dealing with insulating brick. These bricks expand and contract as they're heated and cooled. Okay, so the cement that's used to put these things together must have the same properties for expansion and contraction as the brick itself does. Okay, that prevents cracking. Okay, because if the cement holding the brick together expands and contracts at a different rate than the brick, the whole thing's going to fall apart because that cement's going to crack. And that would be a bad thing. In ceramic chambers, there's a special blanket that you can buy at the supply shop that you use to line old chambers. When you install a blanket to fix a ceramic chamber, caution has to be used to not make it too small. The blanket can also be used as a chamber. Okay, in other words, if the combustion chamber has collapsed, you can buy the same blanket along with some steel binder clips, basically. Okay. Now, nothing can touch this blanket after it installs. You can't use a vacuum on it. You can't use a brush on it. Nothing can touch it after installed because it's going to crumble into little pieces. And that's a bad thing. Okay, so you can reuse specialized blankets and stuff like that. Molded chambers is by far the most frequent combustion chamber you're going to find right now. Okay, it's a semi-insulation material. Okay, it is delicate. It's similar to the ceramic blankets, okay? But nothing is needed to hold it in shape. Replacements are shipped in the same shape that they were originally installed with. Replacement packs also contain a portion of insulating blanket to seal spaces and cracks between the sections. Okay, now combustion chamber, again, your burner is pointed into the combustion chamber. The combustion chamber is usually a little bit larger than the burner hole, the burner opening. So to replace a combustion chamber, a lot of times it involves disassembling almost the entire furnace or boiler in the basement to replace this stuff. Okay, so this is not an easy task. You want to avoid breaking the old combustion chamber whenever possible. They do wear down over time, but you don't want to be the cause of it. So the whole purpose of a combustion chamber is that the chamber acts like a mixing bowl for the hot gas, air, and oil. The best shape is round or oval. Square corners create what we call eddy currents. This is something you need to know. Square corners create eddy currents, which lower the flame temperature. When square chambers are needed, the corners are usually angled. We don't want anything that's a square corner. That's actually a 90-degree angle, okay, because it actually creates eddy currents. Those are air patterns around those corners. We want to be able to angle the corners, so sort of round them. The height of the chamber must be high enough that no flame extends over the chamber walls. Most of our combustion chambers do not have a top. They have a bottom, they have 3 sides, but they do not have a top. That's where the products in combustion go. But the chamber has to be high enough that no flame extends over the top of the actual combustion chamber walls. Questions?
No, sir.
Okay. So, combustion chambers, required part of every piece of oil equipment out there. Okay, you can't get away from combustion chambers. Now, the other required part of oil equipment out there is our chimneys. Does a chimney know if it's supposed to push air out or pull air in? Does a chimney have any regulation on it that says, okay, air goes up or comes down?
No.
No, I've said this before. Some of you guys have heard me say this. Chimneys are relatively dumb. They have no idea what they're supposed to do with the air. Okay, so it's up to us to make sure that the chimneys work properly. A lot of calls you go out on will be because of chimneys and draft issues. That is a primary cause of oil service calls. Chimneys and draft issues. Chimney design can't be changed. Once a chimney is installed in a house, are you going to pull down the chimney and install a new chimney? Not really. Okay, you have to get the best efficiency under all conditions. For example, if you're having a snowstorm in the middle of the winter with high winds, blowing snow, and everything else, it's very unstable air patterns. But your chimneys still have to work properly. Okay, if you're on a hot summer day and your boiler or hot water heater is running to provide hot water for the house, we still have to have chimney venting properly even though it's a hot day and there isn't as much of a draft. So the chimney has to work in all conditions without changing out chimneys. You can't change a chimney. Okay, the draft, the word draft, is the suction of air up a chimney. Okay, hot air rises, cold air falls. Draft is created by heat or natural air currents. Okay, the hotter the chimney gets, the more draft I have. The cold chimney, when you first start the burner, doesn't do well with draft. If created by heat, it's known as a thermal draft. Okay, if we have a chimney And if it's created by heat, the draft, it's known as thermal draft. If it's created by air currents, it's known as natural draft. Wind blowing across the top of the chimney is known as a current draft. Because if you blow wind across the top of a chimney, it's going to alter the draft that's in that chimney. This is outside of your control as an oil burner tech. You cannot control the wind blowing across the top of the chimney. You cannot control air currents as a natural draft. The only thing you can control is somewhat the thermal draft. If adding a fan or blower, we can call it a draft inducer. Okay, I can add a fan or a blower to my furnace exhaust. Okay, and I can use a draft inducer. The induced draft serves as a booster. It doesn't replace the natural draft. It just helps it along. This forced draft handles all combustion gases, and it tries to force it out of the building. It's a Band-Aid. Okay, you shouldn't need it. Now, why do we need draft? We have to have a slight vacuum present in all the combustion areas. Without the vacuum, the flame will pulse and rumble. It will also overheat the chamber. So in other words, my chimney and my combustion area is always under a slight negative pressure from the room around it. Now, some of you have not had the design class yet where we talked about negative pressures. Let me go back a slide here. Okay, so I have a room or a house that a boiler's installed in. Okay, that boiler is connected to a chimney that goes out of the building. Okay, the air pressure in this house is higher than the air pressure in the boiler. The air pressure in the boiler or the furnace, the combustion area, is actually higher than the air pressure that's in this chimney. Okay? So if we're talking about air pressure, we're talking about pressure that's measured in inches of water column. 1 inch water column is the pressure differential required to lift 1 inch of water. Again, 1 inch of water column is the pressure required to lift 1 inch of water. But again, all draft is in inches of water column. It's how we measure draft. It's how we measure small air pressures. 1 psi equals 27.7 inches of water column. This is a number you guys really should know, not just for this course, but for everything you do in the trade where water column comes in. 1 inch of water, 1 psi is 27.7 inches of water column. A typical oil stack draft, that's the draft in the chimney, should be a negative 0.04 inches of water column. Okay, and the official number is chimney draft should be someplace around negative 0.03 to negative 0.05. Okay, so we want our draft to be right around 0.04 in the negative. Basically, negative means it's a lower pressure than the surrounding space. Okay? So it's extremely important that the chimney draft is a negative number. Questions?
No, sir.
We use a draft gauge to measure this. Okay? It's a pulling force over the fire and the stack. We have 2 draft measurements we take. One is over the fire and one is in the chimney. The over the fire is slightly higher than the chimney, but it's still at a negative pressure than the space around it. If a positive pressure exists, it's not going to vent. Air from outside is coming down the stack, known as a downdraft. This is an extremely dangerous condition. Carbon monoxide is going to come into the space. Again, if it's a positive pressure, air from outside is coming down the stack, downdraft. Combustion gases are hotter than the outside air. Hotter means lighter. Lighter means it should automatically rise up the chimney, resulting in a suction over the fire. Okay, this is how this all works. As the chimney warms, as the hot gases start up the chimney, we're going to create draft in the chimney. Okay, there's determining factors of this all. Okay, if I have 1 cubic foot of air per minute at 60 degrees compared with 1 cubic feet per minute of air at 600 degrees, which is going to rise faster?
The 660.
No, the hotter the temperature, the faster it's going to rise. So my air at 600 degrees is going to rise faster. What about chimney height? Okay, again, the higher the chimney, the greater draft we're going to get. It's an enclosed passage. The higher it goes, the greater draft we're going to get. Hot gas, the hotter the gas, hotter the chimney, the increased draft. As the weather changes, your draft will change. On a cold day, when I put hot gas into that chimney, I'm going to have a really awesome draft. There's a greater temperature difference between the chimney and the outside air. On a warm day, we have lower draft. Less temperature difference between the chimney and the outside air. Okay, now you think to yourself, why do I use oil on a warm day? Give me an example. Why do I use oil on a warm day?
For your hot water.
Hot water heaters. Okay, they have to run year-round. Okay, so warm days we have lower draft. We have to be very, very aware of that. Okay, since a chimney is a permanent structure, we consider it to be a constant. The only variables you have are the temperature of the flue gas and the outside temperatures. These temperatures are constantly changing. Okay, the burner the oil system has to take into account these constantly changing variables. Outside temperatures beyond our control. Okay, we can't do anything about that. The temperature of the flue gas is the only thing we can control. We adjust that by the addition or deletion of combustion, which basically means we can add fuel, we can remove fuel, we can adjust the air that's being pulled into the burner. Every time you change a burner adjustment, you affect draft. So when you change a nozzle, when you adjust the air, when you clean the burner, when you adjust the electrodes, every time we change a burner adjustment, you're going to affect draft. Chimneys have to be warm and dry. They must extend 2 feet above any surrounding object. They're required to be vertical and straight. Okay, those are the rules on chimney. Must be warm and dry. Must extend 2 feet above surrounding objects. They have to be vertical and straight. A chimney is cool at startup. Draft will increase as the temperature rises. Over a year of operation, the draft can change. It could start off as a low of -0.02, and it could go as high as negative 0.14. Okay? The draft will adjust over the course of the year. That's because of temperature differences. We don't like change in oil. Oil burners don't like change. Okay, change causes smoke, reduced efficiency, and a high draft at shutoff, which equals heat loss up the chimney. The higher the draft, the more heat is going to flow up the chimney. So what we do is we vary the draft to compensate for any changes. A drop in draft affects the airflow into the chamber. After the proper draft is obtained, the air supply is set. The over-the-fire draft, and those should have negative signs in front of them. The over-the-fire draft should be a negative 0.1 to a negative 0.2, and this is all in inches of water column. Okay? Over-the-fire draft should be a negative 0.01 to a negative 0.02, and it should be in inches of water column. Draft regulators are also known as bypass or air bleed. On any exam you're going to take, it's going to say draft regulator. It uses a swinging door with a counterweight on it. Okay, what this does, as the door opens, the room air mixes with the flue exhaust. It cools the stack gas temperature, lowers the draft, and reducing pressure by allowing the air to enter. We don't want too much draft. So as the draft increases, the weight on the swinging door allows the door to open and allow room air to get pulled into the chimney to control the draft coming through the heat exchanger in the combustion chamber. Okay? The door opens and closes due to changes in room and chimney pressures, and it regulates the draft. The whole proper name is called a barometric draft regulator. The draft regulator is designed to only reduce over the fire draft. It cannot increase draft. Has one purpose, the reduction in over fire draft. It will not increase draft. So in other words, if you don't have enough draft in the first place, the draft regulator can't fix that for you. If you have too much draft, the draft regulator can fix that problem. But it will not fix a situation where you do not have a good chimney to start with. To measure and adjust draft, we use what's called a draft gauge. The first thing we do is check for over-fire draft. Has to be horizontal. The door must be free, and we want to operate the burner for a minimum of 5 minutes before we start checking for draft. Why do I want to operate the burner for 5 minutes before we check draft?
Let it warm up.
Let what part of it warm up? What am I trying to warm up?
The flue pipe.
Combustion chamber?
Both are actually good answers, but the end thing I want to warm up at is the flue in the chimney.
Oh, the flue.
Okay, because I do not have, because before the chimney is warm, we're not in our normal operating position. Okay, we need to be in our normal operating standards before we do much of anything. Okay, lowest possible level of overfire draft, negative 0.01 to 0.02. And again, a lot of times we just show the numbers, but anything over the fire and in the chimney, when we're talking about draft, it's in a vacuum, so it's a negative. If over the adjustment regulator, if over this, we have the adjustment regulators, we set it to open. We keep in mind a second regulator must be needed. In other words, if you have a 0.05, okay, so if we have a negative 0.05 over the fire, okay, my chimney is pulling way too much air. We're going to adjust the counterweight to open this draft to the point that it pulls it down to my 0.01 or 0.02 range. And then we might have to add a second regulator. If we only have a negative 0.01 or maybe not even a negative 0.01. If we go down further than that, I want to adjust that counterweight to slightly close the door. Okay, because this reduces the air being pulled into the chimney and increases the draft over the fire. Is there any question on this?
No, sir.
Okay. Draft in the stack, which is your chimney or your outlet of your furnace or boiler, has to be greater than the over-the-fire draft. Again, we need to keep this negative pressure going on. Our stack draft, okay, is normally in the area of 0.03 to 0.06. Most people use this or this number, and these are, again, negatives because it's a vacuum, okay? Has to be greater than the stack, than the over-the-fire draft. If the stack is too high, okay, if there's too much stack draft, okay, it's an indication of a dirty heat exchanger. Okay, again, let me repeat this. If your over-the-fire draft is good and your stack draft is too high, it's an indication of a dirty heat exchanger. There's no heat exchange taking place. Soot is building up, and it's insulating, and it's allowing that extremely hot air to get into the chimney, come out the vent. Okay? So why do we check our drafts at the end of every service call? Why is that one of our last things we do?
Constantly changing.
Yeah, there's a better answer. Why do I do it at the end of every service call or end of every annual maintenance? Didn't I just mention clean heat exchanger? Okay, part of the importance of this whole process is that you're with a clean heat exchanger. Okay, I want to take it in a clean situation. That way when I get the service call that there's no draft, okay, I have what my numbers should be, and I have a comparison. Okay, if I have a dirty heat exchanger, it increases restrictions. Air delivery falls off, smoke is the end result. Okay, restriction in, okay, heat exchangers. Now, for sizing, I have to have 1 square inch of chimney or stack for every 16,500 BTUs of input. 1 square inch for every 16,500 BTUs of input. Stack sizing has to be the same size as the unit collar. In other words, if the furnace or boiler is designed to have a 6-inch stack, you cannot put it into a 4-inch stack. It must have the same size as the unit collar. Basically, couple rules of thumb: 6-inch round pipe under 1.0 GPH, 7-inch up to 1.5, 8-inch 1.5 to 2, and it goes from there. It's all based on what the BTU input is. Okay, 1 square inch for every 16,500 BTUs of input. For those of you on this call and paying attention, I can promise you that there's going to be some calculations based on this on your final exam. This stuff is important. When we install stacks, we want to stay as short as possible. We want to be uniform in size. In other words, you're not going to change sizing of the stack piping, of the vent piping. You're going to try to run from the furnace to the chimney in one size. We don't use 90-degree bends. We use 45s instead. We join all sections together with 3 screws. And we cement all holes, even at the chimney. We cement it into the chimney using a high-temperature cement. Okay? Very important. The draft regulator is installed between the chimney and the stack control. Has to be a minimum of 18 inches from the control. It must be 18 inches from any combustible surfaces. Okay? Should be 10 inches larger than the stack. Okay, in other words, from away from any bends, 10 inches larger than the stack. You don't install draft regulators right next to a bend. Okay, you don't install draft regulators upside down. The weight has to be at the top or at the side that the manufacturer says, depending on the regulator you buy. Do not install these things sideways. Gravity matters. Okay, so how big should a chimney be? How big should the stack be? Anybody? How big?
Minimum of 18 inches from control. Must be...
Yeah, it doesn't say it on this slide. It's the last slide. How big should a stack be? 1 inch for every 16,500 BTUs input. How many BTUs is a gallon of oil? Come on, folks.
1,440.
100,000.
Damn, that was 3 answers.
140,000 roughly. 140,000. Okay? So just be very aware of your stack sizing. You may not be the one who installed the piece of equipment, but do you think you're going to have to service something somebody else installed?
Every time.
Yeah, and I guess you probably should know before you start your service if you're going to end up with a stack problem. What's the point in spending an hour or so at a call if you have a stack problem? Okay, it's going to be a problem. Now, ventilation is required. Does the combustion process require air?
Yes.
Yes.
Yeah. It's a major requirement of the combustion process. So ventilation is defined in the International Residential Code, okay, under Section 401 in Chapter 4. Okay, venting is required. Fuel-burning appliances shall be vented to the outdoors in accordance with their listing and label and the manufacturer's instructions. Okay, except for those appliances labeled for unvented use. Venting systems shall consist of an approved chimney or vent, or venting assemblies that are integral parts of labeled appliances. Gas-fired appliances, they refer to another chapter. I'm not worried about that right now. A venting system has to maintain draft requirements. Okay? We have to make sure that we always have a flow of the combustion products to the outside atmosphere. That's all we're saying. This is in code. Okay? When an appliance is permanently disconnected from an existing chimney or vent, or where the appliance is connected to an existing chimney or vent, it has to comply with different sections in the code. Okay, this is all about code. Okay, the M stands for mechanical code. Okay, M, mechanical, which is what we're working with, mechanical systems. 1801.31 and 1801.34. Okay, the space surrounding a flue lining system or other vent shall not be used to vent any other appliances. Okay, in other words, we cannot, if we throw a flue or a lining down a chimney, we can't put another appliance onto that into the space surrounding that pipe. Okay, we can't use the unused area unless we put another pipe down the chimney. Okay, this is when you get to an old house with an ancient chimney. Okay, a lot of times that chimney is very large. Okay, so if you look, this is a top view. Okay, if you look down that chimney from the top, you might have a very, very large opening in here. It's too large for the appliances you're now installing. So we can install a lining that lowers the size of that chimney to make it controllable. Okay, you cannot use the space around there for another appliance or a fireplace. Once a lining is installed, you can only use the lining. But this code is also saying, can I put another lining next to the first one and use that? Yeah, you can. Okay. A mechanical draft system, in other words, power venters, draft boosters, can only be used with appliances labeled and listed for such use. We have to put in safety switches to prevent the flow of fuel to the equipment if the system does not run. So in other words, if I have a power venter or a draft booster on the chimney, I have to have some cutouts available. So if the system doesn't run, if the draft system doesn't run, the furnace doesn't stop. Okay? If I have anything that's under positive pressure, like not a negative pressure, if I have anything under positive pressure, everything has to be sealed. The whole objective of all of these rules is to prevent flue leakage of those flue gases into the building. Those flue gases include things like carbon monoxide. There's a thing called a direct vent appliances. Okay, direct vent appliances have to be installed in accordance with the manufacturer installation requirement. Direct vent appliances vent directly out through the side wall of a house or through the basement foundation. Direct vent. Don't use the chimney. Venting systems have to be adequately supported. Okay, in other words, if you run a pipe across the basement, if you run a vent pipe across the basement, it has to be supported. You cannot run a chimney or a vent connector through supply and return air ducts. Believe it or not, somebody has done this. That's why it's in the code. There's been a supply or return air duct that someone decided to run a chimney directly through the center of. Can't do that. Okay, because again, if that leaks, there's going to be the products of combustion that include carbon monoxide that are spread through the building. Okay. Unused openings. Any unused openings in any vent system needs to be closed or capped. Okay, so in other words, if you remove a hot water heater and start using the boiler for the hot water heater instead, we've now reduced the number of appliances. You can't leave that opening in the chimney capped. Okay? A solid fuel burning appliance or a fireplace should not connect to the same chimney as another appliance. Okay, in other words, if we have a wood fireplace on the first floor and a wood fireplace in the basement, you cannot connect them to the same chimney passageway. Again, if you look at the top of view of a chimney looking down on it, there can be multiple passageways. Might be one chimney, but they cannot be connected to the same passageway. By the way, I can't connect oil and gas appliances to the same chimney passageway either, or the same vent pipe. Okay? There's a very strictly controlled type of venting required. Appliances shall be provided with a listed and labeled venting system as set forth in Table M, which just stands for Mechanical Code 1804.1. Okay? Type L, oil vents with oil is what uses oil burning appliances. Type L. Okay? Pellet fuel has different, sometimes, requirements for venting. Again, depends on the appliance. Vent termination, that's where it ends. Okay? What happens above the roof? What happens where it ends? Tells you to look at sections 1804.2.1 and 1804.2.6. Vents passing through a roof shall extend through the flashing and then terminate in accordance with the manufacturer requirements. Okay, you can't install decorative shrouds. In other words, you can't decorate the top of the vent to make it look like a pine tree or something, unless it's listed or labeled for use. And again, refer to the manufacturer's installation. Whole point of this whole thing is to make sure we get the products of combustion out of the building. Okay, that's the whole purpose of venting systems. Natural draft appliances have to terminate at least 5 feet above the highest connected appliance outlet. In other words, if we install something on the top floor, it has the vent has to extend at least 5 feet above, okay, the highest. Natural draft gas vents serving wall furnaces have to terminate at least elevation 12 feet above the bottom of the furnace. Okay, again, as a technician, you're not going to be designing these things, but you do need to know how to troubleshoot it. Why do I care about the number of feet above the appliances? Why do I care about that? How tall the chimney is? What do I care about?
You lose efficiency as it gets taller.
I gain draft as it gets taller, right? The taller the chimney, the more draft I have. Okay? So we're worried about me. What? Go ahead.
No, that's fine.
Okay. Type L vent. They're giving cross references in this code. What does UL stand for?
Underwriter's Laboratory.
Yep, Underwriter's Laboratory. It's our main testing facility in the United States. Basically, the insurance company started Underwriter's Laboratory because they wanted an independent third party to check all of these appliances, check all of this electrical equipment and stuff like that to make sure it's not going to burn buildings down or hurt people. Okay, so everything has to conform to Underwriter's Laboratory requirements. Okay, vent terminals for direct vent appliances need to be installed in accordance with manufacturer's installation instructions. Okay, again, you are not a mechanical engineer. Let's leave the mechanical engineering to somebody who is a mechanical engineer. Okay, don't become a mechanical engineer. Mechanical draft systems, in other words, that means that we are forcing air. We're doing something to make the air move. Mechanical draft systems shall comply with UL 378. Okay? Now, this becomes very important. Again, remember I talked about power venters. They vent out through basement walls. They don't require a chimney. Okay, the vent terminal, which is the end of the vent, it's where all the gas comes out, has to be not less than 3 feet away from any forced air inlet. Okay? Has to be 3 feet above a forced air inlet located within 10 feet. In other words, if I have a wall of a building, let's just say this is a wall of a building, crooked building, but get over it. Okay, if I have a power venter here, okay, and if I have a forced air inlet here, can I have that if it's 2 feet between the two?
No.
No.
No. Why? Why are they concerned about this?
Not less than 3 feet.
Yeah, but
I don't know
what's
the reason why, though.
What's the reason?
I'm not sure.
Think about it. hot air rises, right?
Yeah.
If I'm sucking air in through an opening to bring it into the building for vent intake, do I want those combustion gases to rise and go into that intake?
No.
No, I sort of prefer not to kill the people in the house.
Oh, that's the flue gases, right? Like the monoxide you're talking about? Okay, I get it.
Yeah, this is your flue gas. That's your vent
Right.
termination. Hot air is going to rise. Okay? Has to be located not less than 4 feet below, 4 feet horizontally, or 1 foot above any door, window, or gravity air intake. Okay? So if I have my same wall here, okay, let me erase what I already did. If I have my same wall here, and if I have 2 windows on this wall, okay, 2 windows on this wall, okay, and if this wall is only 10 foot long, okay, and if these windows are 3 feet off the ground, can I install a power vent or any place on this wall?
No. Wait, no.
Not under the windows. Maybe I could get above the windows, but if that furnace is in the basement, I have a problem. Can't do it.
Mm-hmm.
Okay. Now if this were the other my other group that's right now in air conditioning, I happen to know by having seen a design project from somebody when they did the design for their own houses, okay, when they did their heat load and everything on their own houses. I saw some pictures. I know 2 people whose houses are in violation of that code. So again, this is a frequent thing that's forgotten about. These people can never open these windows when that furnace or hot water heater is running, because the product of combustion will come right into those windows.
So they just do that and like they just like, okay, I just won't open the windows instead of fixing it?
Well, I would be very careful on who they is. Building officials normally catch these things, but there are companies out there that will do work without pulling proper permits.
Okay.
Okay. Why do people do work without pulling proper permits? What's your number one? If you had to guess, what was your number one?
Cost effectiveness?
Finances.
Yeah, finances, cost effectiveness.
Timing.
Yeah, permits don't cost that much money.
Patience?
Man,
You don't want to take the time to do it?
Inspectors are usually pretty good, as long as you say yes, sir.
Time to get those permits to come through. Delays your...
I can do a furnace change out without a permit under emergency conditions. In other words, if it's 10 degrees outside or under 32 degrees, I'm allowed to change out a furnace as long as I go and get the permit the next morning.
Damn, I don't know.
What are you required to have? Hey, what are you required to have in order to pull a permit?
Yeah, that's
2 of you talked at the same time. I didn't hear what the other response.
S1?
You have to have a contractor's license. Okay? To pull a permit, you have to have a contractor's license. Now, everybody on this call, I believe, is in the state of Connecticut. If you go to pull a permit as an apprentice or a technician, guess what you can't pull?
A permit?
A permit. So people doing side jobs, okay, you can't pull a permit. A lot of this work that you see, that you're going to see when you get into the field. Guys, I do have to mute somebody.
So you're talking... I'm sorry, you're talking more about your DIYers, right?
No, I'm talking about technicians that are doing side work to make extra money. Like,
Oh.
yeah, like if they have a neighbor or someone like that who doesn't want to call their company to do the install, and they think they're going to get a cheaper rate from the technician that doesn't have all the company overhead and stuff like that. It's called side work. Okay. A lot of technicians do it. It's strictly illegal if you do not have a contractor's license. And a matter of fact, most companies will fire you for it. Okay, it's not legal because you can't pull a permit. Okay. So a lot of unpermitted stuff has wacky installs like that. Again, where are we allowed to? Okay, all of this stuff, if you think through, okay, if you think through why these rules exist, they all make sense. Number 4, the bottom of the vent terminal shall be connected at least 12 inches above finished ground level. In other words, the ground level after all landscaping, concrete, and everything else is done. Why do I care about that 12 inches above finished ground level?
You don't want anything getting in that vent, whether snow, debris, animals.
Primarily, the reason is snow.
You said snow?
Snow. Okay? I don't want a snowbank. Okay? Or I don't want snow just falling before someone has a chance to shovel it out to block my vent. Okay? Why number 5 exists? The vent termination shall not be mounted over or within 3 feet of any oil tank vent or gas meter. What's my reasoning there?
Vents produce heat, don't they?
Yeah, this is classified under things that go boom. Okay? All of this stuff, because there could be vapors here. Vapors are extremely explosive. Gas meters, okay, they have what's called a pressure regulator that sometimes vents just to the outside. Okay? Why don't we allow terminations to be closer than 10 feet from lot lines? That's your property lines or adjacent buildings. We don't allow power exhaust terminations to be closer than 10 feet to a lot line or an adjacent building. Why?
What the?
Don't want any spills that can possibly end up on another property line or another property.
They're hot. That's a hot gas coming out of there. Could be close to 500 degrees. Okay, we don't want somebody to accidentally wander into that hot gas and that hot thing. If you have a building, think about some of the houses in some of the suburban areas or some of the urban areas, the city areas. They're closer than sometimes closer than 10 feet apart, and there's a walkway or a driveway that goes between the two houses. Okay, what happens if some kid wanders down that walkway or driveway and touches that hot power venter?
Yeah, I don't think he's going any further than that.
Well, he's going to get burnt, or she. So we want to be very careful about safety. Okay, it's important. Okay, now, combustion air. That's the air my equipment is going to use as it burns, is called combustion air. Some buildings have enough infiltration. That's air that's coming in through cracks and crevices around windows that additional air is not required. Other buildings, especially newer construction, require us to bring in additional air mechanically. The tighter the house, the more combustion air problems I'm going to have. Let me repeat that. The tighter the house, the more combustion air problems I'm going to have. Because the oil burner uses room air for my combustion process. An oil burner can actually put a house into a vacuum within 10 minutes of operation. Okay, it gobbles in huge amounts of air. The furnace room may be a confined space and need ventilation. Okay, and combustion air from within the main building. When air is brought into a confined space from inside a building, there has to be two holes that air comes through, one high and one low. And again, in the code books, it gives examples of this. I think I walked through it a few weeks ago when we had a brief conversation about code book. But when you have a wall, let's say somebody refinishes a basement, okay, and builds a wall around an oil-fired burner, I can put in a vent to allow air to go in there, but I have to have one high on the wall, and I have to have one low on the wall. Can't just have a high one. Okay, because vents will act different. It might act as a chimney and actually bring the combustion products into the space. Each opening must have a free area, in other words, a ventilation area of not less than 1 square inch per 1,000 BTUs hour. Okay, this is different than our chimney area, much different. Okay, each opening must have a free area of not less than 1 square inch per 1,000 BTUs per hour. This is based on the total of input rating of all appliances in the enclosure. In other words, again, we have a finished room looking down from the top. I have my oil burner, might be a furnace, and I have a hot water heater. Okay, you have to add these together, in other words, so they could be running at the same time, and then divide by 1,000, and that tells me how many square inches of opening in each high and low vent, combustion air vent, that I have to have. Can't be one or the other. Has to be a total of both. When a building has adequate makeup air for the burner, I don't have to do anything. Okay? The building will allow air to circulate on its own. When a building is large and tight, we have to bring in outside combustion air. If it's tight construction, I have to bring in outside air. Okay, one of the ways to do this is to install a vertical permanent opening for combustion air. Has a total free area of not less than 1 square inch per 4,000 BTUs per hour. So again, if I bring in combustion air through a vertical pipe, I have to have 1 square inch in that pipe per 4,000 BTUs hour. So that equals 35 square inches per gallon of oil burned per hour. This is critical. Okay, this is a matter of safety for the occupants in the building. That's a vertical pipe. The rules change when we have a horizontal. If we just put a pipe through a wall, okay, I have to have a free area of not less than 1 square inch per 2,000 BTUs, which is 70 square inches per gallon of oil burned. Okay, of the total of all the appliances. Now, when we talk about free area, this is important. You have a grill, okay? Might have a bunch of cross sections, okay? So in other words, we have a grill to prevent animals from getting into the house. Okay, when we're talking free area, it only is the holes in the grill. It doesn't take into account the cross sections and vertical braces of the grill. So if each of these are 1 inch or half an inch wide, that is deducted from the free area. Okay? Free area. Which means nothing restricting. And again, there has to be 2 openings in every space. 1 high and 1 low. Each opening must have the proper free area space. Any residence built since the mid-1970s may require planned ventilation or makeup air for the oil burner. Any residence built since the mid-1970s may require planned ventilation or makeup air for the oil burner. The screen covering ventilation cannot be a mesh less than 1/4 inch and not greater than 1/2 inch. So the little holes in the mesh cannot be less than 1/4 inch and not greater than 1/2 inch. Why is that?
Too big, and you can potentially get animals or debris inside, I guess.
Yup. Exactly. Why too small? Why don't we want it too small?
You still want the air to flow normally.
What happens in the spring in every area, in most areas of the country? What do I have very heavily coming off trees and plants and stuff like that?
Yep, there you go. That stuff.
Oh, yeah, that stuff. The green stuff, the white stuff, that's all over everything. If the mesh is less than 1/4 inch, it's going to get clogged.
Jeez.
Okay. Ventilation will be ventilated by natural means according to 402 or mechanical means. And again, section 403, everything we do is governed by International Mechanical Code, which is part of the international code structures. Any questions?
No, sir.
Okay, so looking at our course, looking at where we are at. Okay, I've talked about a little bit about International Residential Code. We talked about combustion chambers. We talked about chimney and draft. We've talked about ventilation and combustion air. Tomorrow we're going to talk a little bit more about ventilation and combustion air and probably talk about some sequence of operation. Okay, I am tomorrow going to talk pretty heavily about the oil simulators. Okay, if you have not already done so, take some time, take a look at the simulator, take a look at it in normal operation without faults. I'm going to go over it pretty heavily tomorrow. And I think that's all I have for today if nobody else has any questions.